Hello, my name is Radhik Rardi, and this is my Week 2 update for the Foveated Vision System project. Last week I talked about my code I was writing for my toolkit. Then I had the Foveated Vision System class, the Capture Device class, and the Vision class. I also had a config.py file for controlling the parameter values for each vision, and an example.py file where I actually tested my code. This week I wanted to add a new task for tracking objects. However, since I wanted my highest resolution and lowest field of view to stay in the center, I actually needed to create some hardware to do that. So this week I spent learning about Arduinos and how to use them and building a pan and tilt camera mount. You can see that here. This uses two servos, so it can go on the X and Y. Here's the servos for the X, and this is the Y. So if we can mount a camera on here, we can look in whatever direction we want. So why don't we put this down and we can see some examples of it actually working. Oh, gotta fix my tape because I don't have any screws to hold it down right now. Here's Arduino right here on a board I'm using. A little less interesting. My Arduino code is right here for actually controlling it, although it's in a different language than Python, so I need to communicate to it somehow, and I can do that using the serial library in Python. Since I'm using a camera right now, I can actually run the code that's in my class, which is right here, but it does work. I've tested it because when I run my code, I actually need access to my camera. We'll get an error otherwise. I can kind of show you what it looks like. Right here, we're going to get a weird funky error that says I can't find a camera. So instead, what I've written is another example gimbal to kind of visualize how it's working. So let's run that real quick. Alright, so there's three input values. There's the X, the Y coordinates, and how fast we're going to go. And the X coordinates, the lower it is, so it's going to go to the left. The higher it is, it's going to go to the right. For the Y coordinates, for some reason, the higher it is, it's going to go down actually, and the lower it is, it's going to go up. And then our speed is also kind of backwards, so the lower it is, it's going to go faster, and the higher it is, it's going to go slower. So let's see an example of this actually working right now. So we can put in some coordinate values here. So X is 120, and we'll put Y as 30. So it should move. Oh, actually, I forgot to put a speed value there. We might get an error now. Usually you need 3 values for this actually. So let's do this again. 120, 30, and then we'll go at a speed of 0. So that goes up there, to the left and up. And now we can do it the other way. We'll do 60, we'll go down this time. So we'll do 120, and then let's slow it down a bit. As you can kind of see, it went down slower than it did before. And if we want to put it back to center, that'll be 90. For some reason, the center on the Y is 60, looking straight forward. And then you can, we'll speed it up a little bit this time. Alright, so you can kind of see it moving around here. And this will allow me to actually control it now, to allow me to do some task with smooth pursuit and other attention tasks that I want to program in. I'm actually going to need a new camera though, because I think my webcam will be too heavy for this. I know they sell some cameras online. Also, I need my webcam for other purposes, so I can't be using that. But this is where I am right now. Next week, I want to get a camera, hopefully, and start programming some tasks for tracking. Thank you for listening.